Welcome to Competency 19 Quiz Part 1.
Number 1, what is the value of $7,500 invested for 42 months at 16.4% if the interest is compounded monthly? Okay, the fact that it says compounded monthly tells us we can use our calculator, okay? Meaning our applications. So push apps, and we want number 1. It's already highlighted. Push enter. And also, our solver is highlighted. Okay, now we need to decide what we need to enter. First thing is n. The value of n is the 42 months. So we can put in 42 months, okay? And because that is actually 3.5 years at, it says monthly compounding, so that means it's times 12 times out of the year, so 12 times that is 42, 3.1. Anyway, 3.5 rather. All right, so let's enter and type in your interest exactly the way you see it. Don't move the decimal. Now, our present value is $7,500. Push enter. It mentions nothing about payments during this time period, so just leave the 0. Future value, leave 0 as a placeholder because that's what we need to find out. Okay, now, how many times is it compounded? Well, it tells us monthly. Well, that's 12. So push 12, enter, 12, enter. Now we go back up to our future value and push alpha, enter. Okay, and if you watch any other videos with me, you ignore the negative. That's just something about the application that has to be there. That's the way let's leave it at that. Okay, but we do have a value. We have an option that matches. That's a future value. It's a pretty good future value, actually. Pays to invest, doesn't it? To save money. Okay, let's look at number 2. Now, number 2, you would think it's going to take a lot of writing, but it isn't. Calculator is going to do a lot for us on this one. Okay, a ceramics artist uses 259 inches cubic of clay to create a cylindrical planter as shown below. Okay, there's our nice pretty diagram. It's a good diagram, okay? The walls of the planter are 1 inch, as you can see shown around your diagram. And the artist wants the height and the outside radius to be the same. So this right here is height. Okay. To the nearest hundredth of an inch, what is the value of the radius r? Okay. The first thing we need to do is establish our volume. Okay. As an equation, though. Okay. So that means V equals pi r squared times the height. Okay, if you remember, you need the area of the base times the height. Okay, so that would be our base. Great, I could actually get rid of that so we can see it. Okay, now, but height and radius are the same thing. So for our purposes, volume equals pi r to the third because we want to replace that h with r radius. So that's good. That means this is what we're using. Okay? Yeah, here, let's see if I can do that. Let's do different colors. So the pops. So we can come back to that. Okay. Now, to solve this, to get us a function that we can put into our calculator, that's our goal right now. Okay. So what we need is, okay, let's go back to this. So what we need is we need to subtract the outside, the total radius and subtract out that hollow cylinder. So we're going to do the whole, calculating the whole entire thing, which we've already done. And then we're going to subtract out the inside. Okay, so this is what that's going to look like. Okay, so we can formulate it a function. So let me draw a line right here, show you what we're doing. We're doing the area of the large cylinder minus the area of the small cylinder. All right, let's go back to that. Okay, we have the large one already calculated. That is going to be, so what we need for our area, we need pi r to the third power minus, okay, this is what we're subtracting. Okay, remember we have to subtract all of this. Pi, okay, the small one. What is the small one going to be? Well, this, because we don't have a lot of information, but we do know. See how here at the top, let me highlight this. Okay, yeah, there. This right here, that's R. But what we really want is this part right in here. Well, that's R minus the 1 gives us this smaller radius, okay? So this is what we're doing. We're going to take R minus 1 squared. That would be this bottom part right here. This little smaller radius. Okay, because remember, it's pi r squared. What we need is r minus 1 square it. And then pi r squared, then we have a height. But what's going to happen to our height? Where our height is also equal to r, but we have to subtract out this 1 inch. So that's multiplied times r minus 1 also. Okay? And that would be the smaller one. If you're having trouble seeing that, just stop the video, think about it, write it down. So what we're doing here, let me write it right here. This is R minus the 1 inch. Okay? And then going from top to bottom, that is a smaller radius, and that is R minus 1 inch is equal to our new height, the smaller height. Okay? All right. Let's keep working on this so we have something we can put in our calculator. Let's clean it up. So that's minus what? That is minus pi r minus 1 to the third power. Okay? But we're still not, and actually I've written the wrong thing. This is not an area. I apologize for that. That is a volume. Probably saw me write that and go, she's doing that wrong. Okay, so this is our new calculated volume, the volume that we want. But we were given that value. That's 259. Okay, so, okay, now it works. All right, so we can't put that in our calculator, okay, as is. So if you think about it, we want it to look like a function. So if we put 0 here, meaning that we're going to subtract 259 from both sides. So that would be, oh, and I also made another mistake. Bear with me. R to the third. Okay, so we have pi r3 minus this whole thing, pi times r minus 1 to the third. Now subtract your given volume of 259. That's what we can put in our calculator, and we can do some estimating and get this answer pretty quickly, okay? So where do we put it? You will put it in your y equals, because we're going to graph this. Okay, so we need second pi. Now, for our calculator, to put it into the calculator, r is going to have to equal x. I know that's a lot of replacing of variables, but it's the way we have to do it. So x up to the third, that's caret up and a 3. Now you will have to arrow over for that. Now in parentheses, because, sorry, we are subtracting. In parentheses, second pi, okay, parentheses again, and that is x. Remember, our r is going to have to be our x, minus 1, close your parentheses, caret up to the third power. You'll have to arrow over, minus 259. Okay, let's graph it. Let's see what we get. Okay, looks like we're going to have problems with our window. That's fine. What you need to do is kind of move your window around. So let's go window. The first thing I like to do is check our number 6, where it says Z standard. What does it give me? Well, we have 256 here. That's pretty large. Okay, so, okay, let me just give you window values. So let's go here. See, I have standard window, and that's just not going to work for us. So let's put a -5 in for our minimum x, and our maximum, it has 10. That's fine. Don't mess with the other things that are there. Go right down to your y. Y needs to be -310. Enter, go down to your maximum, make that 20. Now let's push graph. That's not giving us anything. What? Do we have anything? Let's check our equation. Pi x to the third, x to the third, okay. All right, do we have everything on? It should be showing up. It's on. No, I just turned it off. Okay, going back to our y equals, we see that we have an error. We have to close our parentheses right here. If you look at our equation here, after our third power, where I have the cursor, we need to put a parentheses, then subtract by 259. Now let's push graph, and our window should be set, and there we go. We have something that we can work with. So let me go back and show you my window again. It's a minimum x of -5, a maximum of 10. And you could stop your video too if I'm going too fast and write these down real quick, or try it on your own calculator. Now notice I have a minimum for my y of -310 and a maximum of 20. So let's go look at our graph. What that does is it's let us see our graph all the way down here at the bottom, which is something that wouldn't have shown up for us, I think, the way we had it. Okay, and also we had an error. I put in an error, which let you see that it's quick to fix. Okay, so what do? They want this radius. Well, what we need to do is trace, and we need to go to the very, trace it. Oh, no, I'm sorry. We're not going down there. We don't want a minimum. That was another problem. What we want to do is go up here and see how close we get to our root. Now notice I'm going to the positive root. We're not dealing with the negative value over here. On the left-hand side, we want the root on the positive right hand. Okay, when x is 5.68, we're getting close to 0. Okay, and I see an option here that's very close. That would be B. Okay, and I have a suspicion, okay, that we're going to have to estimate. We'll look at our table also. Okay, notice that when I arrowed over a little more, went up a little more, that it gave us a y value that's over, it's too high. Go back. Okay, that's pretty close. So let's look at our table. Second graph. Okay, 573. Okay, very, very close. Yes, we have some rounding going on. Look at how we have negatives, negatives, and we go negative. If we want, okay, look what's happening. And I've changed my values in my options to see this. So you see 3 decimal points at least. When we go between these two, looks like if you leave it at 5.73 rounded, it'll be close enough. Because if we arrow to the next value, it goes over, it's just above 0. So somewhere in between those. So rounding to the value they have for B is correct. We could do all kinds of calculations and probably come up with a value, but then it's going to have to be rounded anyway. So that we estimate with our calculator or round by hand. Doesn't matter. It's the same thing. Okay, this is the first part of our quizzes. I'm going to break these up. But if you like what I'm doing so far, do you mind giving us a like, sharing us out, and if you haven't subscribed, could you do that, please? All right. Thank you so much.